All right, welcome back everyone. In this video, we will be covering more about career statistics and global engineering. And really the goal here is not to have you memorize a million statistics and data points, but instead to give you a picture of what the engineering profession looks like and what the outlook is for you if you do indeed choose to study engineering. So, goals for today. First, we'll talk a little bit more about engineering degrees and the different paths you can take if you choose to get a degree in engineering. We'll also share some statistics about the engineering profession. We'll briefly touch on the grand challenges of engineering, and we'll talk about how engineering is becoming a global profession. Before we get into the details here, let's try a quick review question from our previous videos. Suppose you're trying to design computer networks for use in smart buildings. If you are an engineering manager and you can hire only 3 engineers, which team of engineers would you choose in order to be most successful? Pause the video if you'd like, and think about which team might be the best one for this project. Alright, so if you are trying to design a computer network for a smart building, that might give you some hint about which majors to choose. If you're not sure, you might want to go back and watch our video on engineering majors. In this case, notice we definitely want to have an architectural engineer on board. And if we're trying to design computer networks, it's probably a good idea to have a computer or electrical engineer on board. Notice that having a mechanical engineer or materials engineer, that could be helpful, but the people who really specialize in computer networks are the computer and electrical engineers. So in this case, I would argue that choice C here would likely be the best option, because you could really have people develop that computer network with the expertise. All right, let's go ahead and move on to the new stuff. So first I wanted to share this general figure about engineering degrees and paths. And you'll notice this print up top. I'm not going to cover this particular slide on exams. This slide is for your information only. But I think it's very helpful to look at this slide to see how all the different engineering paths fit together. So most students start their engineering journey either in high school or in community college. So often, as a high school student, you might be taking some engineering courses, or maybe you decided to attend community college and start taking courses there. From a community college, you can start taking courses that could transfer to a 4-year engineering program. Additionally, many community colleges offer associate's degrees and certificates that will give you engineering skills. Typically, most students will choose to either go to a 4-year college and get a bachelor's degree in engineering, while others may choose to get an associate's degree. So notice there's a bit of a difference here. If you want to have access to traditional engineering jobs, typically a bachelor's degree is required. If you have an associate's degree, you can sometimes work your way into engineering roles, but it typically requires quite a bit more work experience. The engineering profession tends to be a little bit biased towards people who have at least a bachelor's degree. So, if you want to be any kind of engineer, it's a good idea to consider getting, at minimum, a bachelor's degree in engineering. The advantage of pursuing an AS degree over a bachelor's degree is the associate's degree will allow you to immediately start working as an engineering technician or technologist. So for students who are looking for more technician or technologist roles, and if you're looking to immediately start working in industry as a technician, then the AS degree could be a good choice. But keep in mind that technicians and technologists are not paid as much as engineers, and they typically do not get to participate in traditional engineering work. Most of the time, technicians and technologists are working more in the technologist role, assisting with building the actual product, not so much on designing. So suppose you went ahead and decided to pursue a 4-year degree in engineering at a college. Once you have completed that degree, many different pathways open up to you. So once you get a bachelor's degree, it's possible to go straight into industry if you would like to immediately start work. Many people do this. Another option, particularly for civil engineers or those planning to work in government roles, is to consider becoming an engineer in training and ultimately going to become a professional engineer or PE. PE certification is often required in some civil engineering roles, so depending on your area of interest, that might be something you need to pursue. Once you have completed the PE training, then you would enter industry, typically in a more senior position, such as a senior engineer. Notice that it's possible to work your way up from just having a bachelor's degree, but typically it would take more time because you would have to gain more work experience in order to reach the senior engineer level. So some students decide that in addition to getting a bachelor's degree, they would like to get a master's degree. And if you get a master's degree in engineering, it's typically another 1 to 2 years of additional coursework after your bachelor's degree. The advantage of getting a master's degree is it gives you a little bit more technical expertise, so you can potentially be hired into industry at a higher level role, sometimes a higher pay grade, sometimes a more senior role. Other times, people with master's degrees decide to pursue a PhD degree and get the highest possible degree. It is also possible to go into a PhD program straight from a bachelor's degree. That's actually what I did. One thing you may not know about PhD degrees is that in engineering, PhD degrees are typically fully paid for by a professor, by research grants, or other funding sources. And so, if you really want to do research and get the highest possible degree in engineering, PhD might be an option for you. The advantage of getting a PhD degree is it qualifies you for certain types of roles that need a lot of research expertise. For example, if you want to work in a government research lab or as a college professor, those jobs typically require a PhD degree. With a PhD degree, you can also directly enter industry, and since you have a high degree, you're typically hired in at a more senior level, potentially a senior engineer. Other people who pursue engineering choose to go into teaching or education, and some even go into medical school, law school, or business. So really the key takeaway to think about here is that engineering degrees can really open up a ton of different opportunities. So even if you're not completely sure about what you'd like to do with your career, if you know you're interested in engineering, it's not a bad place to start. With an engineering degree in hand, you can develop a lot of very useful, very marketable skills that are beneficial in many different career paths. Once again, I do not expect you to memorize this flowchart or this figure, but I encourage you to think about what types of degrees and paths would help you end up in the career or work role that best fits your own preferences. For some students, they may want to go straight to work as a technologist, and that's great. Then you go ahead, get that AS degree, and off you go. Others might want to pursue a master's or even a PhD degree, and that's great too. But it's good to always know what you're signing up for and think about what you need to do in order to get to whatever position you're aiming for. Here's another useful bit of information. I didn't learn about this slide until I had entered engineering industry after completing my degree. But I think it's very good to know, so I'm sharing it with you here. So suppose you were to graduate with an engineering degree and start working for a company. So typically you start out in your career with either an associate's, bachelor's, master's, or PhD degree, depending on what degree you had earned. So typically you would work your way up from an entry-level or junior engineer all the way up to a senior engineer. And notice if you have a higher degree, then you may be hired in at a higher level upon graduation. But at a certain point in your career, you need to choose what type of role do you want to be in. And there's really two parallel tracks that most engineers follow. Some engineers really want to lead a team. They want to be managers. So some engineers choose to take the management track. These are people who want to lead a team of engineers. And you'll see that engineering managers can later be promoted to directors, vice presidents, senior vice presidents, and even CEOs or higher level people in a company. Other engineers don't want to manage people. Other engineers just want to be an expert in an area. Those engineers go down what's called the technical track. So rather than managing people, these engineers stay as individual contributors. They develop expertise and a set of skills so that they can help and develop new technology. You'll notice that parallel to the management track, engineers can be promoted all the way up to roles that are equivalent to a VP of a company. So one of the highest roles you can get as an engineer would be a distinguished engineer or fellow, which is equivalent to a vice president in the management track. So depending on your interest and what type of work you like, engineers can be both individual experts working on a project, or you could be a team leader. And generally, at some point in your career as an engineer, you would typically choose one of these paths to go down, although some people move between the two. Let's now talk about the actual statistics about the engineering profession. And so for this part of the class, we will review some data from our textbook. And I'd like to remind you that you do not need to memorize all this data. Instead, please focus on the key takeaways that are highlighted in these lecture slides. Really, the main purpose of the book chapters is to help you see what the current engineering profession looks like. I want you to know what you're signing up for, so you can make a more educated decision about whether engineering's right for you, and if so, what kind of engineering might be the best fit. So let's go ahead and start with kind of a fun graph here. This graph shows a correlation between per capita consumption of mozzarella cheese and the number of civil engineering degrees awarded. Why would I show you something like this? Would there really be a correlation between mozzarella cheese and civil engineering doctorates? Yeah, probably not, right? This is a pretty crazy correlation. If you've seen the movie or the book Freakonomics, you might remember that correlation between data does not necessarily mean causation. Correlation does not mean causation. Basically, what we're saying is just because these two things are related to each other, that does not mean that one caused the other. So, key takeaway here, whenever you see someone else's data, make sure you question it and analyze it for yourself. This data is kind of more for a joke and just to be funny. It's just a coincidence that these two things happen to be related so closely. Okay, so now let's look at the actual data about our engineering careers. So this comes from chapters 3 and 4 of the Engineering Your Future text. Some of this data may appear a little bit outdated. Some of it's from like 2010, 2013, but it's still relevant. And I think it still gives a fairly good picture of engineering over the years. Here's our first data plot. This plot shows the number of engineering students. And so you can see there's a year down on our horizontal axis, and then on the vertical axis we see the number of undergraduates in the solid line, and then we have the number of graduate students in a dashed line. And you can see overall there's some ups and downs, but in general, the number of people studying engineering is increasing. Notice that doesn't necessarily mean the number of graduates is increasing. Probably does, but this is just showing that more people are enrolled in colleges to get an undergraduate or graduate degree. Next plot. You can see that more people are graduating from high school. Most likely part of the reason why more people study engineering is because there's more people coming in from high school. Let's take a look at another statistic. This plot shows the number of engineering degrees awarded per year. And you can see on average, there's around 80 to 90,000 bachelor's degrees, up to 100, roughly 50,000 master's degrees, and roughly 10,000 PhD degrees are awarded per year. These are degrees in engineering. So again, lots of people get bachelor's degrees, fewer people go for the master's, and fewer still go for the PhD. Here's a little bit more numbers about degrees awarded. And I don't expect you to memorize these numbers. If you're curious, you can take a look at the majors of interest and see how many degrees were awarded in that discipline over the past few years. Couple things to note. You can see which degrees are most common. Many people choose to study civil and electrical, and notice computer engineering is also extremely popular. So civil, computer, electrical, and mechanical are the most popular degrees as of this plot being made in 2014. You can see that some other degrees are also growing fairly quickly. For example, bioengineering has been steadily growing. Another good statistic is to look at engineering employment. So this figure here shows the number of employed engineers and this is in millions. And so you can see that the number of employed engineers is fairly steady. There's a little bit of a rise and a drop due to economic cycles, but overall, the profession's fairly stable. That's because engineering is still fairly in demand. There's a pretty significant need for people with engineering skills. So key takeaway here, overall picture of the profession is fairly stable employment. And the number of engineering jobs continues to be about constant. Even if you happen to be affected by a layoff, if you live in an area like the San Francisco Bay Area, there's a lot of tech jobs around. So often, people who are laid off or affected by cuts at one company can still find employment at another company nearby. Here's another graph showing engineering unemployment. So notice this compares the unemployment rate of the US overall, that's the dashed line. So overall unemployment with unemployment for engineers. So notice that the two lines follow a similar trend, but the unemployment rate of engineers continues to be well below the unemployment rate of the general population. So again, this tells us that engineering is generally an in-demand profession. Engineers tend to be needed, and their skills tend to be very valuable to have. All right, so many students like to study engineering, or they're interested, in part because engineering jobs pay competitive salaries. So here's some salary numbers. Again, take these with a grain of salt because they are from 2016, 2015. Also keep in mind that these are salaries overall for the entire US. And in high cost of living areas like San Francisco Bay Area, the salaries tend to be considerably higher. So here you can see that engineers tend to be among the highest paid of college graduates. Computer science and math and regular STEM also tend to do fairly well. But consistently, salaries of engineering graduates are among the highest of all college graduates. And part of the reason for this is because there's often a shortage of qualified candidates available to fill jobs. So, with supply demand, lower supply means that the pay will be higher. Engineers are in demand. And again, these salaries here shown are specifically published as salaries for graduates with bachelor's degrees. If we break down salaries by discipline, you'll see that there's a bit of variation across discipline as well. For example, if you want to make the highest salary possible, you may want to consider petroleum engineering. You can see that petroleum engineers are among the highest paid out of all engineers. But still, across the whole profession, overall, all the engineering disciplines do pretty well. One of the reasons petroleum are paid more highly is, again, due to supply and demand and the need for engineers with that skill set. I don't expect you to memorize these salary numbers, but just take a look and can get a sense of kind of what the numbers are looking like. And remember, in San Francisco Bay Area and other high cost of living areas, the salaries do tend to be higher. Here's another plot about salary over time. So you can see on the vertical axis, we have salary in thousands of dollars, and then on the horizontal axis, we have years since our bachelor's degree. And you can see that the salary tends to always steadily increase. An engineer's relative salary holds up well for many years after graduation. So ideally, assuming that you continue to grow and develop your skills, hopefully your salary will also continue to increase during your career. Next comes the supervisor salaries. So as you can see in this plot, we can look at this is the different percentiles of supervisor salaries, and this is across all engineering degrees. You see that in general, supervisors and those in management roles tend to earn higher salaries than those who are not in supervisor positions. Next is salary versus degree earned. So this plot shows the salary versus years since bachelor's degree. And notice you can see that the PhD is this top line, followed by the master's degree and the bachelor's degree. So you can see that those who have master's and PhD degrees tend to earn higher salaries compared to bachelor's degrees. However, the amount of work experience you have will also increase your income. Here's another interesting statistic. Many organizations are interested in increasing the number of students from underrepresented groups. This table shows the percentage of female and minority students in engineering as of 2014. So this is percentage of all undergraduates. And you can see that across the different minority groups, the total percentage varies a bit. The key takeaway you should remember here is that the percentage of women in engineering is about 20% currently, and the percentage of underrepresented minorities in engineering is about 15%. There's a lot of organizations who are working to help increase these numbers, and so if you're interested, I'd encourage you to reach out to some of those engineering organizations that support the students in these different groups. All right, next comes practicing engineers in the US. So this bottom axis shows the number of engineers in that discipline, and our vertical axis shows the major, or the discipline. Once again, we see that the most common engineering groups are electrical, civil, and mechanical. So if you're undecided about engineering, one approach you could consider is choosing one of these majors, because overall there's just generally a fairly high demand for those jobs. Notice that there's a fairly small number of engineers in the agricultural, marine, and mining sectors. They're just more specialized professions, and there's less demand for those particular areas. Let's go ahead and try a quick review question here. See if you remember. Enrollment data currently shows that percentage of women in engineering is about some percent, and percentage of underrepresented minorities is about another value. Do you remember what these numbers are? If you need, you can go back and peek in your notes. And remember, in our key takeaway, we saw that there's about 20% women and about 15% underrepresented minorities. Okay, so now let's think a little bit about what employers actually want. How can we prepare ourselves to be competitive candidates if we're in the market for an engineering job? One study found that employers are really looking for the total package when they hire graduates. So what this means is that they're looking for more than just the degree. Many employers do require a minimum of a bachelor's degree, but they also want people who have other skills like communication, interpersonal skills, teamwork, leadership, technical proficiency. Employers want students and employees who can learn quickly and continuously, people who can problem solve and use common sense. They also want new employees who are hardworking, who take initiative, and employees who can handle multiple tasks. Notice that your engineering classes that you might take in school, these are not necessarily taught in class as much. So often, you want to take advantage of other opportunities to develop these skills. For example, maybe you can develop these interpersonal skills at work, maybe in projects, clubs, internships, maybe even as part of research or other programs. But this is a really important point to bring up, that certainly it's a very important thing to actually get a degree in engineering, but I would argue equally important is your ability to have these other soft skills and interpersonal skills so that you can work with teams and communicate. So the key takeaway here is that earning an engineering degree is really no longer sufficient. In addition to having an engineering degree, it's a good idea to devote time to develop those other competencies. So again, that's our interpersonal skills, communication skills, teamwork, multitasking, all these other skills. So let's look at some ways that we can actually develop these skills and make ourselves more marketable to employers. Okay, so once again, a lot of textbooks and courses don't really cover this, but let's go ahead and just cover a few recommendations. How can we make ourselves more marketable for the real world? How can we better prepare ourselves to succeed in an engineering career? One way to make yourself more marketable is by getting a graduate degree. So, as we mentioned in the flowchart earlier, getting a graduate degree qualifies you for a higher salary and a higher level job, such as a management job or a higher technical role. And as we saw, some jobs, like professors and researchers, some jobs actually require a master's or PhD degree. And while it is possible to do higher level roles with just a bachelor's degree, often it requires more years of work experience in order to reach that point. Here's an important point, though. This is not always emphasized as much as it should be. More senior engineering jobs generally demand more working hours. You get paid more, but you are often expected to work longer and harder than people in less senior engineering roles. This is a really important point to consider, because depending on your own personal situation, your needs may be different. Some people want to make as much money as possible, and they don't care how many hours they work. Some people are extremely invested in their career and they want to rise to the top of the career ladder. If that's your goal, that's perfectly fine. Be aware that in order to reach that goal, you might have to work very long hours and work very, very hard. Other people want to have families, and they want to accomplish other things outside of work. For people in those positions, it might be less beneficial to have a very high senior role in engineering because it would be a lot more challenging to maintain the work-life balance you want. So the key takeaway here is that getting a graduate degree does qualify you for a higher salary and higher level jobs. Keep in mind that people in higher salaries and more senior roles tend to be expected to work longer hours than people in less senior roles. So at the end of the day, I'd encourage you to think about finding the right balance for you personally. A little bit more about graduate degrees. What do graduate degrees require? This chart shows the typical time required to get an engineering degree. This assumes that you are a full-time student and you are not working outside of class. So keep in mind, these numbers may vary. If you're working part-time, then it may take you longer because you have to spread your classes out over more time. So typically, a bachelor's degree can take around 4 to 5 years. A master's degree requires a bachelor's degree plus 1 to 2 more years of study time. So getting a master's degree will require 1 to 2 more full-time years of classes, and usually you or your employer pays for it. Some employers do have tuition reimbursement programs where they will help pay for your master's degree while you're working. So maybe you take one class at a time over the course of several years and you complete your degree while working. PhD degrees are a little different. PhD degrees typically require 4 to 6 more years beyond a bachelor's degree. So you basically take the same classes as a master's student, and then you spend the rest of your time doing research and completing a PhD thesis. So usually you do not have to have a master's degree before starting a PhD, but it depends on the program. Most programs will allow you to apply with a bachelor's degree. Here's another very important point about PhDs. PhDs in science and engineering are usually free. You actually get free tuition and a salary. PhDs are usually covered by research and teaching assistantships. For example, during my PhD, I was paid around $30,000 a year as a salary, and then I also completed coursework, did research, and was also participating in research and teaching assistantships for the school. Next point. Another way to make yourself marketable is by getting related experience through work or other clubs. It's very hard to learn interpersonal skills out of a textbook. So, by joining clubs, extracurricular groups, or even through your own work, you can build leadership and teamwork skills. And once you figure out what kind of skills you want to develop, you can try to get work experience related to those skills. You can also look for opportunities to work in labs or do internships. There's co-op or volunteer opportunities. And you can even try learning or building things on your own. So the key takeaway here is, when possible, try to get engineering or teamwork experience. This experience is really helpful evidence to employers. This helps prove to employers that you have strong teamwork, communication, and interpersonal skills. It shows that in addition to having a degree, that you are motivated and interested in your area. Here's another way to get more marketable: networking. So as much as possible, during the course of your education, try to get to know your professors, classmates, and other people in the industry. Believe it or not, people you know may be able to connect you to opportunities. In the beginning of your career, your network may be fairly small. But over time, as you meet more people, you may be able to connect to even more opportunities. In prior videos, we mentioned professional organizations. And getting involved with those organizations can also help you build your network. So key takeaway here, building up your own personal network can help connect you to opportunities as well. Next one. Another way to be marketable is to look at where the industry is headed. We mentioned how the National Academy of Engineering has prepared a list of the 14 grand challenges facing engineers. So if you gain skills and knowledge related to several of these grand challenges, your skills will probably be in high demand. These are important problems that engineers need to solve in the future years. Once again, here's the list of those 14 grand challenges of engineering. I don't expect you to memorize these, but I could ask you to name a grand challenge and explain why it's important. Really, the key thing I think you should do here is think about what grand challenges you are interested in and what skills you might need in order to work on those challenges. Let's do a couple quick practice questions. Go ahead and pause the video if you'd like, and see if you remember the answers to these questions. This first question asks, which of the statements about graduate degrees in engineering is false? We're looking for the false statement here. Take a moment and think about it. All right, let's go line by line. Choice A. Having more experience beyond a bachelor's degree helps you stand out. This is true. Choice B is also true. If you have master's and PhD, you tend to get paid more, and you tend to be qualified for more senior roles. C is also true. Getting a graduate degree, it allows you to complete more coursework and have deeper knowledge. Choice D is a false statement. People in more senior roles actually tend to work more hours. So it can be a blessing and a curse. It can be nice to have a more senior role, be paid more, but in exchange, the expectation is often that you work harder and longer than those in less senior roles. Let's do another practice question. Which of these is true about a PhD in engineering? Take a moment and think about it. All right, let's go through it together. Choice A is actually false. Most PhD programs allow you to enter even with just a bachelor's degree. You often get the master's degree on the way to the PhD. Choice B, you have to pay for 4 to 6 more years of school. This is also false. Remember, PhDs are usually free in science and engineering. In other disciplines like the humanities, you might have to pay, but typically in science and engineering, your PhD will be funded by research grants, fellowships, teaching assistantships, and other sources. Choice C is true. As we mentioned, you do get free tuition and a salary as a PhD student in engineering. Choice D is false, though. As part of the PhD, you do a lot of research. So, research is not for everyone. If you're not interested in research, the path might not be for you. For those of you who want to do research and gain a very deep knowledge in an area, a PhD could be a really interesting path. All right, so if you have any other questions about these career topics, please feel free to reach out. I'm always happy to talk about career stuff in help hours. Let's go ahead and finish up with our last topic for today, international and global engineering. So, just an FYI, engineering is a global profession. And more, as an engineer, there's a good chance you will be working with international teams at some point in your career. I certainly did. And as an engineer, I went on business trips to Europe and Asia and all over the US. It's almost unavoidable to be working with teams located in different places. So it's important as an engineer to be aware that there are many factors globally that affect engineering. It's good to know about what factors drive the global economy because these factors can also affect engineers. One big factor affecting the global economy and engineers is changing world maps and political alliances. So, many American companies will want to expand into international markets, but sometimes if there's conflicts between the US and other countries or kind of conflict going on in the world, that can affect engineering. For example, in engineering, many companies use suppliers from Asia, and tariffs and trade restrictions can interfere with these relationships. And sometimes you actually are not allowed to share information or work with vendors from certain countries. there are these laws called export control laws, which limit the countries that engineers are able to work with. So, political alliances, conflicts, trade wars, these can certainly affect engineers. Another factor driving our global economy and engineering is mergers, acquisitions, and partnerships. Pretty much every industry can be affected by buyouts, mergers, and corporate actions. So, one day, your company might be bought by a company located in another country. And all of a sudden, travel, communications, and interactions with your team can become global. Another factor driving the global economy are trade agreements. For example, NAFTA, North American Free Trade Agreement, was created to try to stimulate economic growth and trade among North American countries. If you are an engineer based in an American company, you may find yourself traveling more in North America and trying to use suppliers based in the US in order to benefit from this agreement. Also, European Union has emerged, and so this is also now one of the big trading partners that you may work with as an engineer. So really the key takeaway here is that almost every industry has opportunities for engineers to work with global teams. The industries in this list are especially international. So if you go into automobiles, manufacturing, construction, pharmaceuticals, food, petroleum, chemical processing, computers, electronics, telecommunications, environmental, consulting, or sales, you're probably going to be especially involved in international work, international teams, and international travel. So, how do we prepare for a global career as an engineer? It helps to learn a foreign language and appreciate international cultures. Also, if you can do any study abroad or exchange programs, those can be very helpful. And often there are opportunities to do international internship work or co-op experience. All of these things can help you be more prepared to work with global teams. Let's go ahead and finish up with a couple review questions. This question asks, which of the following is not a major driving factor causing engineering to become a global profession? Go ahead and pause the video. See if you can find the right answer. All right, so looking at this list, you can see that choice A and B are both true. Many companies want to expand, and industries could be affected by buyouts, mergers, or other actions. D is also true. Because of trade agreements that might affect or discourage trade in certain countries. Choice C is the false statement. While it might be fun to go on business trips and meet with international teams, this is not considered a major driving factor causing engineering to be a global profession. All right, so that's it for this video. So hopefully now you have a better idea of how engineering is becoming a global profession and what you're signing up for if you choose to become an engineer. I'd highly encourage you to think about what engineering majors and functions interest you most. And this week in class, we'll also further think about career by working on resumes, cover letters, and your 5-year plan. I would highly encourage you to use these assignments to help you succeed, both in this class and wherever you go next. And if you have any further questions about career stuff, I'm more than happy to discuss in a separate session, or feel free to reach out. In our next videos, we'll be starting to look at engineering fundamentals and the problem-solving process. Thanks everyone for joining the fun, and we will see you in the next video.